Good morning, Math 11. This is Mr. Chang, and today we'll continue with Lesson 5, Part 2, on reciprocal functions. Yesterday we looked at linear function, and today's lesson we're going to look at quadratic function. The good thing is, well, math is consistent, so we'll follow the same recipe of drawing reciprocal function for linear function for quadratic function. So what recipe am I talking about? I'm talking about the 4 steps that we use in drawing the function. So let's turn to page 480 in your notebook. And now I'm going to use example number 2. So here I have a quadratic function. So the function that I have is quadratic. F of x is a quadratic function because it's x squared minus 4. So as you can see here, they give you a table of values. The gray color is the quadratic function. Okay, as you expected, it has the shape of a parabola. It has the lowest point in here at 0, -4, and it has 2, 0, one at -2, and one at 2. Now, when you construct a table of values, so this is what we have right here. And now we are introduced the concept of reciprocal function. Okay, whatever function I have, now I take the reciprocal of it. So all the y value changes to its reciprocal. Remember, reciprocal function is a vertical change only the y changes. So 12, now these are all the numbers on the parabola, and 12 become 1 over 12, 5 become 1 over 5, 0 become undefined, and so on. And you know, if you have 1 and -1, they will say 1 and -1. So let's follow the same recipe, all right? The first step is this guy here, 0. Well, in the case of quadratic, how many zeros do we have? Not just one, we have 2. So here is my 0. What do they turn into? You're right. I can hear you. It turns into a vertical asymptote. So let's add it here. It turned into a vertical asymptote. We can give it an equation, x equal to 2 and x equal to -2. X equal to a number give you a vertical line. And step number 2 is you draw the invariance point. It's not on a table of values, but it doesn't mean it doesn't. But then if you look at the graph, you find it. Okay, where do you find it? You look at the value of 1. You look at where the grade line cross 1 is here. Well, it's where it's crossed with the answer because those are the invariance point. Are there more? Yes, there are 2 more. Down here at -1. 1 is here, 1 is there. So for this graph, in total, there are 4 invariance points. Exclamation mark. Now, third step, y-intercept. So for this graph, what's the y-intercept? Well, in here is also the vertex, and you're going to do a vertical change. The y-intercept is here, 0, -4, and -4 will become -1 over 4. So you mark it on your graph. Where do I mark it? I mark it right there. Remember, it's a vertical change, so the point can only move up and down. If it starts moving left and right, then it's a horizontal change. It only moves up and down. The height of -4 become the height of -1/4. So I have so far 1, 2, 3, 5 points of the new graph. The 2, 0 become asymptote. Now 4, I'm going to draw the curve. Before I draw that, I first add a horizontal asymptote there at the x-axis with equation y equal to 0. This divides the whole plane into 6 regions, okay, in which 3 of the region, this region, and that, this region, and this region has nothing. So there's no graph should be drawn there. And then the remaining region, when you look at this part now, well, we are familiar with this shape. I just draw the following. It crosses 0, it crosses at 1. When it gets smaller, when its smaller part become big and big part becomes small, right? And then for this part, we know how to do it. Just do it this way, just over here. And finally, the part in the bottom is new, okay? You need to cross the new y-intercept. You need to cross the 2 invariance point. And then this little bit here become long. This little bit here become long. And then you just join. So you have this shape. So we have done. The black line in here is the yellow line, is the reciprocal function of a quadratic function. If you plot it in your calculator, you will see the same thing, right? In your calculator, enter y1 equal to your quadratic function, and then enter y2 equal to 1 over your quadratic function. Make sure you put the brackets there. And then you will see the graph you see here. Okay. All right, let's look at some example that we can actually try and draw ourselves. So like they have some fill in the blanks here. I'll skip all that. It's okay. We have summarized it. Yeah, I'll just skip all that. I'll just go to the writing. We finished this part as well. These are the 4 steps. All right, 1, 2, 3. I combine 4 and 5 into just drawing the curves. So those are the recipe of drawing reciprocal function. All right, let's look at page 482, example number 1. Here we go. You are given a graph, and obviously it is a quadratic function. They tell you x-intercept is at 2, y-intercept is at 3. Y-intercept at 3, here we go. Here is my y-intercept, x-intercept at 2. All right, let's use suggestions on previous page. Let's draw the graph. And then they also give you the line y equal to 1, y equal to -1 as a guide. Okay, anyway, let's first step. Okay, first step, what do we do? Draw and can you everyone recite the first step? Okay, say it. All right. So 0 become y asymptote. Here we go. First step. Second step. Positive and -1 become the invariant point. Look at this parabola. How many ones and -1s does it contain? Well, what are you looking at? You're looking at when the y value is 1. So you can imagine a line at 1 where it crosses your graph. You see something moving on the screen? So this point is the invariant point, and this point is the invariant point. So there are 2 ones here. Do we have any -1? The answer is there isn't. So that's my step 2. My new graph will cross these 2 red dots. Step 3, y-intercept. The y-intercept is here is 3. What does it become? Yes, you're right. It becomes negative 1 over 3. Okay, 3 become 1 over 3. So somewhere down here. And number 4, let's draw the curve. Okay, well, before we draw the curve, we draw a line here. We can give it a name, or this one is x equal to 2. There's only 4 region here. All right, there's only 4 region. Let's look at this region for now. Just look at this region here. All right. If you look at this region, you have a line going up. We know that for this part, right, like for this part, when you take the reciprocal, it's become big number. Okay, so this part will become this part here. Maybe I'll use a different color. Okay, so I'm drawing the reciprocal graph starting from 1. It's just approach the vertical asymptote. And then on the other side, it will just approach the 0 and make sure it crosses the new y-intercept, and then it go this way. And then on the other region, well, I'm looking at this region now from 1. So, all right, this part from 0 to 1, it become big number. It become this. And then that part, they become small. So it will just become something like that. And that's your graph. Okay, we're following the same 4-step recipe and you get all the answer. Okay, you can plot it in a calculator, you will get the same thing. Let me answer the questions here. Say the y-intercept of the new graph will be 1 over 3 because the old graph is 3. The new graph is 1 over 3. Given the graph of this function is this, say the equation of that. We'll just take 1 over that. So the new graph is 1 over whatever the function is, just like that. When you have fraction of fraction, we like to flip them. So the 3 is the numerator here. It becomes a denominator, so stay in the bottom. The denominator here, because you have a denominator of a denominator, you flip the 4 to the top. So the final answer, you have a 4 up there, 3. Okay, so that's the final answer in simplified form. And use a graphic calculator to verify the graph drawn. And you did it, and here we go. All right, let's see more example. Okay, more example, happier you will become. Example number 2. Shown the quadratic function f of x. Okay, here we go. The x-intercept are integers. The maximum value is 2. All right. So the maximum value is not on the y-axis, somewhere there. Okay. And then they are integer values, so it's 1 and -2. They are the x-intercept. Sketch the graph. Okay, let's sketch it. How do we do it? We follow the 4 step. First step is 0 become asymptotes. Here we go. And here we go. Give an equation of the line. Easy, just write that. Not too difficult. Now, second step, invariance point. How many invariance points are there for this graph? Okay, is it 1, 2, 3, or 4? You're right, it's 4. Okay, so let's mark them on the graph here. 1 and 1. Now, some students have trouble understanding what's 1 and -1. If you can separate x and y, you can figure that out. We talk about when the y value is 1, when the function is 1. So you look for the height of this parabola. When it reaches the height of 1, you mark it here. It's go to 2 and come down to the height of 1. Okay, and then go to the height of 0 and then go to the height of -1 here. And then on the other side, go to the height of -1. So there are total 4 invariant points. Now you draw the y-intercept. Okay, so the y-intercept is here. Is about 1.8. So right, like it's just a rough figure, 1.8. So if you flip it around, is close to 1/2, somewhere there, just roughly. Okay, just a rough number. But then we can draw the minimum. Okay, so first step, the third step, you can draw the y-intercept, or let's draw the minimum or maximum. The maximum here is 2. When you flip it, it will become half. Okay, let's say right there. Okay, let me erase the y-intercept. The y-intercept should be slightly higher. Okay, but the minimum is here. Okay, let's finally drawing the curve. I'll add a horizontal line there. Do you remember? Look at the look at this part. This will be the answer. Okay, look at this part. This will be the answer. How about the middle part? It has to go through the middle point, 1/2, have to go through the invariance point. There's asymptote there. This little bit become absolutely large. So here we go. It just come around like that. So that's my graph. Okay, so let me highlight it again. So here, going through this one, going through the invariance point 1, reaches the lowest point, -1/2, crosses the new y-intercept, cross at 1, and then go here as long as it don't touch the asymptote. And then for this side, we'll both cross the invariance point. On this side is approach the asymptote. Here approach the x-axis, which is another asymptote. And same for this side. They all look like this, so it's not too bad. Okay, B. State the equation of the asymptote of the line. Okay, we did it already, which is there are 3 asymptotes. And then question C, the point A half lies on the graph of the reciprocal function. State the value of A. Okay, well, what are they talking about? The point where it reaches y value of half is talk about the maximum point. Okay, so the maximum point, I don't know, maybe let's say it's -1/2. So it's around -1/2, like this point. They talk about what was this point. So roughly -1/2/2. Unless they give you more information, otherwise you can't answer exactly for this question. Okay, so that's about it. You can try the homework. Let us right. That's all the. Well, there's one more example, but I think I will save it for next time. So you can try the homework question. The homework question is question 2, 4, 5, 7, 9 to 11. 2, 4, 5, 7, 9 to 11. Work on that. Work hard. And for tests, we will postpone it. It won't be next Tuesday, won't be Wednesday, Thursday. I want to move it to Friday, next Friday. At first we say Thursday, but let's have one more day. We can do it next Friday. All right. So here we go. That's it for this unit. We're almost done. So practice and make sure you ask question when I see you next week. Bye.